thing we need to do with this one is find the region that's being talked about, because we need to know what are the limits of integration. So over here it is a -1, and over here it is a +3, which of course you could do by setting these equal to each other and factoring. So those are going to be the limits. One assumption we make in Math 3B is that this has the same density everywhere you go. So if this is a metal sheet, it's made of the exact same metal everywhere you go. So that density, we usually use the constant rho. Since at the end it gets divided out, I'm not going to include it in this work right here. So we would have, first of all, for the mass, it's going to be integrate from -1 to 3, the top function, which is the 2x plus 3 minus x squared. So those are going to be x squared, a 3x, and minus x to the 3 over 3, evaluated from -1 to 3. Let's see, when you substitute in a 3, this is going to be a 9 plus a 9 minus 3 is cubed over 3. So that's a grand total of 9. And then when you substitute a -1, this will be a +1 minus 3. And then this is going to actually become a +1/3. So there's 3 negatives there, a fourth one there. So this is a 1 minus a 3 and +1/3. And now we need to subtract that. So minus -5/3, which means that you actually add it. So that's going to be 27 and 5 is 32/3, or 10.667, depending on if you want decimals or fractions. I'll use fraction. And you can check and make sure that we got that right by going over here and saying, all right, what we're really integrating is this one minus this one. And then calculate the integral. The graph is going to look different than the original because I just subtracted them, but we should get, this was 10.667. So let's see, from -1 to 3, 10.667. All right, we're on the right track. We got 2 more integrals to go. The moment about the x, you then integrate from -1 to 3. And then this is the one that has 1/2. You subtract the 2 functions, and then you add the 2 functions. So it's going to be the 2x plus 3 minus x squared, and then the 2x plus 3 plus x squared. So you could multiply out these 3 terms times these 3 terms, or you could realize this is really the difference of squares. So the middle terms, so if you just group this together and look at it that way, it's something minus something squared and something plus something. So we really just need the first one times the first one, and the last one times the last one. So that's going to be, this one times this one is a 2x plus 3 being squared, and then this one times this one is minus x to the 4th. And then that's what we need to integrate. So this one is going to be 2x plus 3 cubed over 3. But then don't forget, this one would have the chain rule, which would have the derivative of the insides at 2, so we need to divide by a 2. Or if you don't like that idea, go back here and use U substitution, and it will do the same thing for you. And then we've got minus x to the 5 over 5, evaluated from -1 to 3. So let's see, in here we're going to have 2 times 3 is 6 plus 3, so we've got, this is 6 plus 3 is 9. So we've got 9 to the 3. We've got 9 to the 3, and then that's divided by a 6. Maybe I'll just wait on the calculator for a second. So I've got 9 to the 3 over 6 minus 3 to the 5th over 5. Okay, there's the first part. Minus, now substitute a negative 1 in there. So a negative 1 is going to make this negative 2. To combine with this is just a 1. So we've got a 1/6. And then minus a negative 1 in here is going to be negative, but with that is now going to be positive 1/5. Okay, now it's a good time for the calculator. Let's see, we've got 1/2, and then 9 to the 3rd divided by 6 minus 3 to the 5th divided by 5. And then subtract from that, now 1/6 plus a 1/5. And then to be consistent, since I'm working in fractions, 544/15. All right, just one more integral to go. So my, the moment about the y-axis, is going to be integrate from negative 1 to 3. And then it's going to be this guy. Again, he shows up in the show all the time. There, and the next one. But this time it's just multiplied with x. And there is no 1/2, it's just an x. So go ahead and distribute that. So integrate from negative 1 to 3. We would have a 2x squared, a 3x, and minus x to the 3. Good old algebra. And now integrate those. So the first one is going to look like 2 and then x to the 3 over 3 minus 3x squared over 2 and minus x to the 4 over 4. Double check those. All right. And then evaluate that from negative 1 to 3. So this is going to be 3 cubed is 27. 27 times 2 is 54/3. This is going to be 3 squared is 9, but then 9 times this, so we have minus 27 over 2. And then this is 3 to the 4th is 81 over 4. And now substitute a negative 1. So this will become a negative 2/3. This will become just a 1 times the 3, so we still got minus 3 over 2 there. And this, if you have a negative 1 to the 4th, it gets rid of the negative and gives you 1/4, but then minus that. So let's see. 54 divided by 3 minus 27 divided by 2 and minus 81 divided by 4. And then subtract from that a negative 2/3, subtract 3 over 2, and subtract 1 over 4. Grand total is negative 40 over 3. Okay, so then we need x bar and y bar. They both get divided by the total mass. And then x bar actually comes from the moment about the y. So negative 40/3. Actually, the thirds are going to cancel. We just need 40 divided by 32. And then this one is going to come from this mx, or the moment about the x-axis, and so 544 over 15. So let's see, x is going to be a negative 40 divided by 32, negative 1.25, and then this one, 544 divided by 15, gets divided by 32 divided by 3 is at 3.4.